Hello everyone, I'm Tolga. I'm a third-year student in Bilkent University Electrical and Electronics Engineering Department, and I'm taking EEE474 class, which is Foundation of Magnetic Resonance Imaging, and this is my course project presentation. I will present you a concept called double inversion recovery, which is one of the sequences of magnetic resonance imaging which is widely used in medical imaging concepts. So I will start with a brief history of magnetic resonance imaging, and then I will pass to double inversion recovery. I will talk about its usage areas, I will talk about its theoretical background, and finish my presentation with showing some images and compare them with other sequence images. So magnetic resonance imaging is a widely used concept in medical imaging. Its initial name is actually nuclear magnetic resonance. However, due to the negative approach against the word nuclear, this word is eliminated and it's called magnetic resonance. This concept is found by Edward Mills Purcell and Felix Bloch, and actually we know Felix Bloch as MR students because his equation is widely used, and these two physicists have contributed largely in NMR concept. So their contributions brought them Nobel Prize in Physics in 1952 and opened the way of many developments in medical imaging and microwave radar concepts, but we are concerned in medical imaging part of this foundation. So this process has evolved with contributions of Letterbohr and Mansfield. These two people have adapted the NMR concept, nuclear magnetic resonance, into medical imaging concepts, and their research brought them Nobel in Medicine and Physiology in 2003. And as I have mentioned before, I will aim on explaining double inversion recovery sequence of magnetic resonance. In magnetic resonance imaging, there are many concepts, many sequences, and these sequences have some positive effects and some negative effects, so they are used in different imaging purposes. For example, for brain imaging, like for nuclear, for imaging the lesion load of the brain, for example, or imaging white matter or gray matter, or their mixage, double inversion recovery is a useful concept. For example, for another imaging purpose, which are not in my research topic, can be used for imaging other parts of the body. So, what is DIR in long double inversion recovery? Its name comes from actually 180 degrees non-selective inversion pulses, as two non-selective 180 degree inversion pulses are used. Its name is double inversion recovery, and these inverting pulses are denoted as TI1 and TI2 in mathematical background part of this concept, this sequence, which I will show you in the further part of the presentation. So, where this concept is used, where this sequence is used. The main usage areas of this pulse sequence is estimation of lesion load, delineation of white matter plaques of multiple sclerosis, detection of infraternium spinal cord lesions, and differentiation of juxtacortical from mixed gray matter and white matter plaques. Now, in this part, I will talk about theoretical background of this sequence. Actually, our main aim in this sequence, usage of this sequence, is actually imaging white matter of the brain, or cerebrospinal fluid of the brain, or gray matter of the brain separately. And this requires nulling other signals from the tissues. Therefore, if we want to actually image the white matter of the brain, we must null the gray matter, or we must null the cerebrospinal fluids signals. And this requires actually choice of correct choice of inversion times for the sequences. For example, in this part, TI1 and TI2 values, which are inversion times, as I mentioned before, can be chosen or can be just selected for different tissues. For example, TI1 can represent gray matter and TI2 can represent the white matter. And if we choose correct values for them, we can image one single tissue without facing any problem. So now I will move on with the mathematical expressions for this part.